Hey everybody, so we are still working with differential equations, but now we are going to start looking at graphing slope fields. And really all this means is that we're going to start looking at a visual representation and trying to find the solutions to differential equations visually instead. So just as a quick review, we're going to solve this differential equation, and list 5 possible solutions. So this should start looking fairly straightforward to you now. So dy over dx is equal to negative sine of x. We know that the first thing we're going to have to do is multiply both sides by dx so that we can separate our variables. So we have dy equals negative sine x dx, and we are going to integrate on both sides. We know that the integral of 1 dy would just be y, and the antiderivative of negative sine of x is cosine of x plus c. So this would be our general solution. All right, but this one is asking for 5 possible solutions. All that really means then is we need to take this plus c and just make up some numbers for it. It doesn't matter what they happen to be. All right, so we could have something like y equals cosine of x plus 1. Or we could have something like y equals cosine of x minus 1. We could also have simply just cosine of x, because it could mean that our plus c is actually 0. Or really, we can come up with anything we want for this c value. We could even do minus 100. Or let's see, we need a fifth one. So y equals cosine of x, let's do plus 15, whatever. All right, but there's 5 possible solutions. Now, really, there are infinitely many because we can come up with any value that we want for c. All right, it could be a fraction, it could be a decimal, positive, negative, doesn't matter. But these are 5 possible solutions. So the big idea here is we want to know how can we represent all of the solutions without making a list. So that's where slope fields come in. All right, a slope field is a graph that helps us visualize the solutions to a differential equation without solving or making a long list. So let's see what this problem looks like. Make a slope field to represent all of the solutions to dy dx equals negative sine of x. Then draw the graph of the solution that passes through the point 0, 3. So the first thing we need to talk about here is that dy dx, that is the slope that we're talking about, right? That's a derivative. That's the slope of the tangent line. So dy dx, anytime we see that, we know it's asking for a slope. All right, the other really important thing to pay attention to here is that our slope is equal to negative sine of x, which means that the slope only depends on x. That is not always the case. Sometimes it depends on x and y, and that makes it a little bit harder. So it's kind of nice to start out with an example where it only depends on x. All right, now there are a lot of points on this graph. Now, normally you will not have to do a slope field for this many points, but to show you guys exactly what it is we're looking for, we wanted to give you something where it was nice and easy to see all these points together. So, we will not normally do this, but for this one, we're going to make a table to help us kind of organize our thoughts here. If you need to do it every time, that is totally fine. You are more than welcome to, but you'll notice as I go on in the video, I won't make tables. All right. So since this only depends on x, we only need an x value here, and then we're figuring out the slope. So we're figuring out dy dx. And we're going to go ahead and we're going to use all of these x values that are shown here for us. So we're going to start with negative 2 pi. And really what that means is we're going to take negative 2 pi and substitute it in. So we know that if we think about our unit circle, negative 2 pi means we're really going a full circle in the opposite direction, but we're still ending up at 0. So the sign of negative 2 pi would be 0. And then making that negative, well, we don't really need to do that. That would still just be 0. So to show that on our graph, what we're going to do is we are going, oh, I should have changed colors. Oh well. We are going to any place where the x value is negative 2, we're just going to draw a little segment that has a slope of 0. So I'm just going to draw a little horizontal line on each of these dots, because that means it has a slope of 0. Okay? Then our next x value is negative 3 pi over 2. So the sign of negative 3 pi over 2 would be 1, and then I want the opposite of that, so that's going to be negative 1. So any place that the x value is negative 3 pi over 2, we're going to have a slope of negative 1. It doesn't need to be exact, we just need to show that it's a negative slope, and it needs to be roughly at 1, at a slope of 1. So all of these are just going to look like this. Okay, oh, that one got a little steep there. That should be a little, but that's okay. I'm sure you guys get the idea. All right, our next x value is negative pi. So the sign of negative pi would be 0. So negative 0 is still just 0. So every single one of these has a slope of 0 as well. Okay, then let's see, what do we need next? Negative pi over 2. So the sign of negative pi over 2 would be negative 1, and then the opposite of negative 1 would be a positive 1. So every single one of these x values is going to have a slope of positive 1. Oops. I don't know why that last one is always the one I mess up. Sorry, guys. All right, let's keep going. Then we're at x equals 0. So the sign of 0 is just 0. So all of these are going to be horizontal lines as well. They all have a slope of 0. And this is why having it only in terms of x is really nice, because all of these x values are the same. When our slope is in terms of x and y, it makes it difficult and we have to do each and every point separately. All right, then let's do if x is pi over 2. So the sign of pi over 2 is 1. The opposite of 1 would be negative 1. So all of these have a slope of negative 1. Okay, let's keep going. Pi. So let's see, the sign of pi would be 0. So 0, so all of these are horizontal. And then we have 3 pi over 2. Ooh, can you guys see that okay? Oh yeah, I guess you can. Okay. So the sign of 3 pi over 2 would be negative 1. The opposite of negative 1 would be a positive 1. I'm going to make my table a little bit bigger there. So all of these have a slope of positive 1. Okay, yeah, good. You guys can still see that. All right, and then last but not least, we have 2 pi. And we know the sign of 2 pi is 0. So all of these are going to be horizontal as well. Again, you will never have to do a slope field for this many points. We're just trying to help you see what's going on here and see how to find these values. All right, the next part of this said that we need to draw the graph of the solution that passes through the point 0, 3. So remember, this slope field here is showing us all of the possible solutions to this differential equation. All right, we only want the one that goes through the point 0, 3. So the point 0, 3 is right here on the graph. And we can see, well, what we're going to do, let me back up a second. What we're going to do is we are going to try and sketch the graph based on these slopes that we were given. So we can see that right here at 0, 3, the graph is going to be pretty flat, okay? So I'm going to go ahead and just make it a little flat. And I can see here that it had a positive slope leading up to it. So I'm just going to do a positive slope. And then it turned into a negative slope. And we can see it kind of flattens out again. and turns to a positive slope and then starts to flatten out. And we can guess based on the pattern that it's probably going to end up going back down again. All right, then on this side, here's that negative slope, and we can see it kind of bottoms out again. And then it has a negative slope here, and it kind of maxes out there, and we can again assume it kind of goes back. So hopefully you can look at this and you can recognize that that looks like a cosine function. Well, if we go back up here where we actually solved this differential equation, we did get that it was a cosine function. So hopefully that should make sense to you that that's what the graph would actually look like. Okay? Let's look at what else we've got here. We have a couple more examples to talk about. So graph the following slope fields for the given points, then answer the follow-up questions. So this is a little bit more reasonable, right? But what we need to notice here is that this differential equation, the slope is in terms of x and y. So it is a little different than the last one, but it's still not too bad. So the first thing I look for whenever I do any of these slope field questions is I look for something that's going to be easy for me to graph. Well, I can see that if my x value is 0, that this whole slope is going to turn into a 0, which means anywhere on the x-axis, my slope is going to be 0. So I'm going to go ahead and actually draw that in right away. We can see that all 4 of these points are going to have a slope of 0 because the x value is 0. Well, that just knocked off 4 of my points right away. All right, so the next thing I need to do is pick a point, and I'm going to substitute in the x and y values and figure out the slope. So I'm going to start with the point 1, 1. If I plug in 1 over 1, that's 1, and I need it to be negative. So the slope at 1, 1 is going to be negative 1. Then if I pick the point 1, 2, that's going to be 1 over 2, and it's going to be a negative, which means the slope here at the point 1, 2 is negative 1/2. So it's still going to be negative, and it's going to be a little less steep than the one that we drew. So it's going to be maybe like that. Then let's look at the point 2, 1. Well, that's going to be 2 over 1, and it's going to be a negative, which means it's going to be a negative slope, and it's going to be steeper than the one we drew before. Then the point 2, 2, all right, well 2 over 2 is going to be 1, and we're going to make it negative, which means the slope here is negative 1. Again, don't worry too much about the steepness of each of these. We just need to have a general idea of kind of what's going on. The big idea for sure is making sure you know whether it's positive or negative, all right? Then let's look at the point 1, negative 1. Well, 1 over negative 1 would be negative 1, and it's got to be the opposite of that, so this is going to be a slope of positive 1. Then the point 2, negative 1, so 2 over negative 1 would be negative 2, but we're making it negative, so that's a positive 2, which means this is going to be a little bit steeper. Then the point 2, negative 2, well 2 over negative 2 would be a positive 1, and then we're going to make it, 2 over negative 2 would be a negative 1, and then we're going to make it positive, so it's a positive 1. 1 over negative 2 is going to give me negative 1/2, and I make it negative, so it's actually a positive 1/2. Okay, so this might be a good opportunity for you guys to pause the video while you try and figure out what the rest of these points would look like. I'm going to draw the rest of them in, but I'm not going to talk through it for you, okay? Okay, so it should look something like that. Again, we're not super worried about the exact things here. All right, let's take a look at some of these questions. So these are good questions that might show up on the AP exam when they're asking you about slope fields. So why do you think that you were not asked to graph the slope field on the x-axis? So something we need to be careful of is on the x-axis, the y values are 0. And if we look at our differential equation here, we can see that the y values are on the bottom. We can't divide by 0. We know that that would give us an undefined slope. So since y is in the denominator, all points on the x-axis have an undefined slope. All right, part B says, do you notice any patterns in the slope field? Well, the first pattern I would point out is the one that we graphed first. We know that all points on the y-axis have a slope of 0. All right, let's see. Something else that I notice is that all of the points in quadrants 2 and 4 have a positive slope. So in the second and fourth quadrants, have a positive slope. And then conversely, all the points in the first and third quadrants, those are negative. So they have negative slopes. All right, so you're going to have to be able to not only draw the slope fields, but then kind of analyze what's going on there. Part C here, which can kind of get lost if we're not careful, says sketch the specific solution that passes through the point 0, 1. So if we want to pass through the point 0, 1, this is something that we kind of ran into in the Desmos activity today in class. So we need to be careful. If we're passing through the point 0, 1, we know that our graph is only going to be above the x-axis then, because that's where our initial point is. So if we look at it, it's kind of maxing out there, and we can see it has a positive slope here, and then it turns into a negative slope. So it's something kind of like this. All right, and if we were to actually solve this differential equation and use this initial value, we would be able to see exactly why it's only the positive portion of the graph that we are going to be drawing in. Okay? All right, I know this video is getting a little long, so I'm going to work through this next one a little bit quicker, but I still want you guys to see it, so we're going to talk about it. All right, so let's see. This one, our slope is still in terms of x and y, so we want to look for tricks. All right, well, we can see here it's x to the fourth times y minus 2. Well, anytime x is 0, that's going to make this whole slope equal to 0. So that means anything on the y-axis is going to have a slope of 0. And then we also know that anytime this in here is equal to 0, we're going to have a slope of 0, which means if y equals 2, the whole slope turns to 0, which means these 2 points also have a slope of 0. Okay? Then we need to just figure out these other 6, so that's not a big deal. If we look at the point 1, 0, well, 1 to the fourth is 1, 0 minus 2 is negative 2, 1 times negative 2 means we have a slope of negative 2. The point 1, 1, we would have 1 times negative 1. That means this is a slope of negative 1. If we look at the point 1, 3, that would mean 1 times 1. So that is a slope of positive 1. The point negative 1, 0, well, negative 1 to the fourth is still positive 1. And then this would be negative 2. So 1 times negative 2 would be a slope of negative 2. Then negative 1 to the fourth is positive 1. 1 minus 2 is negative 1, so this would be a slope of negative 1. And then for the point negative 1, 3, we would have 1 times 1, which is going to give us a positive 1. So our slope field should look like that. Alright, so this asks us to describe all the points in the xy plane for which the slopes are negative. So really what this is asking you is, where is dy dx less than 0? Alright, well, if we take a look at these slope fields, we can see that anything that's under here has a negative slope, except for these values here. Alright, so what we're going to say is slopes are negative for y less than 2, except for these values here, which means we have to say that x cannot be equal to 0. All right, and that should make sense because if we look at our equation, we know that anything in here where y is less than 2, that's going to give us a negative number here, and that's going to give us a negative slope then, except for, of course, when x is equal to 0, because that makes the whole thing equal to 0. All right. Thanks for hanging in. I know that was a little bit longer and probably kind of annoying, but once you see it once, I think you're okay. So hopefully we should be good. We'll do tons of practice. I'll see you guys later. Bye.